Alright guys, so welcome back. So here's going to start the stuff with polar, where we're going to get into the idea of how to graph and working with the graphs of polars today. Not an actual full function, just how polar coordinates work, how they plot, distance, stuff like that. So everything we've done so far has been rectangular coordinate system. We got a little bit into the parametrics, obviously the last two videos there, but everything you've done really since you've learned how to graph has been rectangular. X and Y axis, horizontal vertical lines intersecting at the origin 0 or origin O. And you plot points based on the appropriate vertical and horizontal distance from the origin. Vertical is up, down for positive and negative, horizontal right and left for positive and negative. So if I want to plot, like, for example, 2, -3, you go horizontally positive 2, vertically down 3, and there's your 2, -3 right there. So when it comes to polar coordinates, it's a different kind of system, so how we plot is going to be different. It's based on the idea of distance away from the pole and then its location angularly wise from that pole. So the coordinate point in polar coordinates is r comma theta. R recognizes the distance, essentially the radius something is from the pole, the origin location, and then theta is the angle you're going to rotate around to create that. So plotting points, positive angles are going counterclockwise, whereas negative angles are going clockwise. R being positive, you get to align the terminal side of the angle. When R is negative, it's on the opposites of the terminal side. We'll kind of get into what that really looks like when I do a couple examples. I'll do one of each scenario. Both of them positive, R positive, theta negative, R negative, theta positive, and then both of them negative, and how that works out. So here we're going to plot this first point, 4 pi over 12. So the 4, you'll find that here we have this, in this polar coordinate form here, we have radius rings of 1, and then 2, 3, and then 4. So obviously the radius of 4 is the outer ring. Radius of 3 is that inside 1, then 2, and then 1. And as for the angles, well, they're all going around this pole here based on the unit circle, but we are going to include these pi over 12 locations that we didn't have on the unit circle because they weren't exact nice numbers, but they were there. Because essentially, if you remember the unit circle, the 30 and 60s were 30 degrees from the axes, but the 45s were 15 away from the angles there. Here, everything is 15 degrees apart, or really pi over 12 apart. So we'd have these additional pi over 12 locations here, as well as obviously our pi over 4 is there in the middle. Now I'm not going to keep on writing this out every single time, so you want to make sure you take a second and pause the video here and write out what the appropriate pi over 12 locations are going to be around there. Now when it comes to applying this, what you're going to do is you're going to go to the ring that has the radius of 4, the angle that's pi over 12, which is right here, and that's the appropriate coordinate point location of 4 comma pi over 12. So when they're both positive, it really is just that straightforward. Now, when the radius is negative, what you're going to do is you're going to go to the appropriate ring, which is radius of 3. So radius of 3 is kind of this second from the outside ring. 3 pi over 4 would go right there. And that red dot would be positive 3 pi over 4. But if I want to plot it at negative 3, what we do is now is we follow along that line, kind of drawing it straight across to the other side. And right there, the blue dots, that's the appropriate negative 3 comma 3 pi over 4. So what you're doing is you just find where it would be as a positive R value and then go across the opposite quadrants. So if you're in quadrant 1, you'd go across to quadrant 3. Quadrant 2 to 4, 3 to 1, 4 back to 2. So again, that's our answer right there. Now, when it comes to having a negative angle, what you're going to do is you're going to find a coterminal angle. It's the easiest way of doing it. So you would have negative 5 pi over 4 plus 2 pi, which is really saying negative 5 pi over 4 plus 8 pi over 4, which is 3 pi over 4. So you're really going to plot 1 comma 3 pi over 4. So 1 is the innermost ring, 3 pi over 4 is again this angle right here. Innermost ring, that angle, that's our location right there. All right, so we don't need to worry about going to the opposite side or anything like that. We're just finding a coterminal angle to find the equivalent location in our unit circle. Now, if they're both negative, again, we'll do our coterminal. So negative 5 pi over 12 plus 2 pi, which would be 24 pi over 12, gets us 19 pi over 12, which is down here. Positive 3 would be right here. So then the negative 3, we travel across to the opposite side, which is right here. So the answer, the red dot, is our correct spot. All right, so obviously you would probably not want to have all that drawn there. So after you find the point based on r being positive and go across, you just kind of erase all of that stuff. And that's our appropriate location. So those are your 4 different scenarios when it comes to finding and plotting your polar coordinate points. Whether r and theta is positive versus negative, your 4 different possibilities. Really just have to watch out for when r is negative. Theta being negative is just coterminal. Review back to, unit 6 if you have to. Now we can find the distance between these 2 points. And the polar distance formula is kind of similar to your regular distance formula, but also a little bit different. In fact, you should recognize this is based on the law of cosines, because that's essentially what you're going to do. Is you're going to create a triangle between those 2 points, and then the pole origin 0, 0, and then you're solving for the distance between them, so you're creating that side angle side, which is then the lengths of the 2 radii, and then the angle in between them is the difference of the angles, and that's what we're creating for this. Like with your regular distance formula, regular slope, or anything else like that, the order you do them in, which one's R1, which one's theta 1, as long as they match, that's fine. Which one you call R1, R2, doesn't matter, just be consistent. R1 is going with theta 1, R2 then goes with theta 2. So here, if I just kind of go left to right, this would be R1, theta 1, this would be R2, theta 2. So my distance would be the square root of my R1 squared plus my R2 squared minus 2 times R1 times R2 times cosine of my, so they have it as theta 2 minus theta 1, so 13 pi over 12 minus negative 5 pi over 4. So we get 4 plus 1 plus 4 cosine of, well, so if we have 13 pi over 12, it becomes a plus 5 pi over 4. That's really 15 pi over 12 for a common denominator, so it's 28 pi over 12, which reduces by 4 to be 7 pi over 4. So we get 5 plus 4. Well, cosine of 7 pi over 4 is root 2 over 2. So we get the square root of 5 plus 2 root 2. And we're leaving it in that format right there. As we kind of talked about back when we did some stuff involving, I think that was with Unit 7, we talked about like the half-angle formulas. We talked about radicals inside radicals, and there is a formula behind that, but not one that you need to truly worry about. So we can leave it inside there. If the MSQ wants a decimal, then obviously just make it the decimal value for that, but I'm going to want you to leave it as an exact value. All right, so that's all we're really doing for our distance. Just watch out. Recognize that when it comes to cosine, if we did it the other way around, if I had said this one was R2, this one's theta 2, this one's R1, theta 1, your angle would be a negative. It would be cosine of negative 7 pi over 4, but when it comes to cosine of negative angles, the negative cancels, so it doesn't really matter with that. All right, so for this one, again, we're kind of going left to right. Well, you know what? Let's make this one R2, theta 2. We'll make this one R1, theta 1, just to kind of show you if it was reversed with that. So your distance would be the square root of 2 squared plus 4 squared minus 2 times 4, cosine of 0 minus 5 pi over 6. So 2 squared is 4, 4 squared is 16. 2 times 2 times 4 is 16. We get negative 5 pi over 6. And again, remember, cosine of negative angles, we ignore the negative. It's really just simply cosine of the positive, then 5 pi over 6, which is a negative root 3 over 2, which when multiplied with negative 16 gives us a positive 8 root 3, and that's our polar distance between those 2 points. So again, doesn't matter which order you do them in, as long as the r and theta matches up. Remember your negative angle identities. Take the negative just cancels from cosine. We don't have to worry about that. We're setting up that particular formula. All right, so that's our polar plotting information, which we're going to use now in the next section, 10.4, when it comes to the idea of graphing these polar functions. So I'll see everyone next time for that particular video.